Okay, following the procedures, which is the first step, is set up the circuit as shown in figure 1. This figure 1 is circuit diagram already gave, and the decode resistor is as the Rx, and set the Rx as 200 ohm, and raise the voltage from the power supply 3 up to 12 voltage, and record the measure values for current intensity for table 1. As we get the result same as the calculation. The first step is we have to calculate first by using the Ohm's law. So using the multi-sim, so what we have to do is example for the lab is we are drawing the circuit diagram, and the resistor Rx, which is Rx, we have to maintain and find the current intensity. So what we have to do for the example, for this one, and cut this one to find the current intensity. Okay, and run. So we get the current intensity of 15 milliampere, as same as the calculation, which is 15 milliampere 3 divided by 200 and get the 50 milliampere. And another step is 6 voltage. What we get is 30 milliampere, same as the calculation theoretical. And the next step is 9 voltage. The resistor must be maintained 45 milliampere for 9 volt. And lastly, for the table 1, which is 12, and the current intensity is we get 60 milliampere. As the result is we just same with the theoretical. So this is how we get the answer for the table 1. Thank you.
Going on with table 2. The procedures say that set the voltage on the resistor as 5 volt and change the resistance value by the following order: 68 ohm, 100 ohm, 1k, and 4.k kilo ohm and 10k kilo ohm by adjusting the decode resistor. And second, record all the measure current intensity in the table 2. So this is the circuit that were given in the lab 6. Okay, by using the multi-sim, this is the circuit that we were given, and this is the first resistance that we used to find the current intensity. So we just click run and get the value of 73.529 milliampere. And for the second is 100 ohm, we just change the value to the 100 ohm and then click run, and then we can get 50 milliampere. For the third, which is 1k ohm, we change it to 1k. Sorry. Okay. And then we click run, and then we can get result of 5 milliampere for the current intensity. And then for the fourth one is 4700 ohm. Change it also the value of the ohm. Okay, and peak run, you can get 1.064 milliampere. Then for the 10k ohm, change it to 10 and peak run you can get for 500 microampere. So this is the result for table 2, whereby current intensity that we measure is 73.53, and for the 100 ohm we can get 50 milliampere, and for 1000 ohm we can get 5.00 milliampere, and 4700 ohm we can get 1.064 milliampere, and then lastly for 10k we can get 0.500 milliampere. Now it's the 500 macro, so we change it to milli, we can get 0.5 milliampere. For the current intensity theoretical, we can use the formula of Ohm's law, whereby V equal to IR. We must find the current intensity, so V over R. So whereby I equal to 5 over 6/8, we can get the 73.53 milliampere, same as the ohm for 100 and 1000 and so on. We can get the same result as using the formula Ohm's law.
Let's continue for the question Ohm's law using multi-sim simulation. For the question 1, from your data table, examine what happened to the current when the voltage was double, triple and quadruple. The answer is, when the voltage is double, the current also double. When the voltage is triple, the current triple. When the voltage is quadruple, the current also quadruple. We continue for question 2. Based on question 1, what type of relationship do you believe exists between voltage and current? And the answer is, when the voltage increase, current also increase. Voltage is directly proportional to current. Next, question 3. From your data table, examine what happened to the current when the resistance doubled then folded. The answer is, when the resistance is double, the current is half, and when the resistance is then folded, the current is single. For the question 4, based on question 3, what type of relationship do you believe exists between current and resistance? When the resistance increase, current decrease. Current is inversely proportional to resistance.
Now we move on to questions and discussions. Question 5. By using Excel, plot a graph of voltage V versus current intensity MA for simulation and theoretical result in table 1. So from table 1, we just take the whole column for voltage and current intensity, where voltage we use is 0, 3, 6, 9 and 12, and current intensity is 0, 15, 30, 45 and 60. We just copy this table and we put in Excel, and the y-axis we use is voltage V and the x-axis is current intensity I. You should get a graph of directly proportional because the graph passes through 0. Now moving on to question 6. By using Excel, Plot a graph of current intensity MA versus resistance ohm for simulation and theoretical result in Table 2. So from Table 2 we have calculated earlier, we just take the column of current intensity I and resistance R, where current intensity is 73.53, 50, 5, 1.064 and 0.5, and resistance we got is 68, 100, 1000, 4700 and 10,000. So we just copy the table and put it in the Excel. We put the y-axis as current intensity I and the x-axis as resistance. We should get a graph of inversely proportional, which satisfies the formula, Ohm's law formula, which is V equals to IR, where I equals to V over R, so I will be inversely proportional to R. So this is how you do question 5 and 6. That's all. Thank you.